Okay, so I'm going to walk through my term project. I'm going to start with the problem context. So my problem is all about gardening and creating a garden plan. So first I want to walk through the old process to explain some context and just show you how manual the process was. So this is literally my garden plan for 2024. I started just by making a list of everything I wanted to garden. And then I do recycle these inventories from previous years, but this would all be manual. So I would write down the vegetable name, the amount I want to garden. I would decide whether I'm going to start it in a seed box, sow it directly outside, or buy it from my local nursery called the Flower Bin. And then I would have the dates based on my hardiness zone, days till harvest, which a lot of this isn't super consistent, potential harvest windows, and then companion planting. So I have friends and foes, things that I shouldn't plant near or I should plant near it. And then some notes from the previous year for each vegetable. I also have a garden map based on my particular garden beds and their dimensions. And again, this would all be manual. And lastly, I have some reflection notes. I have not updated this for this year yet. So that being said, I chose to use Python and DataFrames in order to solution for this particular problem. I chose DataFrames because I thought there were multiple benefits compared to a lot of the structures we learned in our course. I don't have to iterate through them. I can import large amounts of data and I can update values for multiple different nodes or data points at the same time. I thought it would be visually effective. I didn't quite get to being able to print out a map with this. I didn't have enough time. Maybe if I had another week, I could get there. But I was able to output some data frames so that my users could look at some data. And I'll go through all the different functions. I also use lists and dictionaries, lists very similar to the ones in C++, basically an array where order does matter. And then I also use dictionaries just to hold two variables at a time. And that was helping with just the square foot component of my project. So in order to see the data frames, I actually have the data in Excel. So I had 4 different tables. I have vegetable traits. So over here we have vegetable name, which is my key for all of my data frames. We have number per square foot, the startup cost of a unit, days until harvest. This is going by the assumption that you plant everything from seed at the last frost date for your hardiness zone, and whether they're shade or sun plants. I have hardiness zones, so depending on your hardiness zone, the last frost date, which means the first date that you can plant, the first frost date, which is usually the end of gardening season, and season length, which is actually just a calculation between these two. I have foes, so to simplify things, instead of including friends, I only included foes because while there are beneficial plantings, really what you want to avoid are the enemies or the foes, and everything else can be planted next to each other and they'll not necessarily benefit, but it'll be neutral. It won't be negatively affected. So not every vegetable has a foe, but I included the ones in my vegetable, my main table that do. And again, another great part about data frames is that I can have a many-to-one or many-to-many relationships, or in this case, one-to-many relationships when it comes to foes, which is great. So it allows some of the relationships to be dynamic, whereas a lot of our data structures, it kind of has to be a little static. And lastly, crop rotation. This had to do with mapping. Unfortunately, I didn't get to this in my project, but this is something I could do in the future, where basically I have my project proposal. Let's see if I can pull that up. It's not up, but basically every square in my bed would have an associated number. And so we would assign each number in each bed a vegetable, and then in order to continue mapping, we would need to know the neighboring squares. So unfortunately, I didn't get to that, but this is the data structure that I would pivot in order to accomplish that. Now going into my code, we went through that. The first thing I did is import my DataFrames into Python. And the reason it's great to do this is because a lot of this information isn't going to change. You know, veggie traits aren't going to change. Your hardiness zones, really, they only change them every couple of years depending on climate change. Foes will never change. And crop rotation will change once a year. So that is something that the user can update. And lastly, reflection notes. Since I didn't update it for this last year, I just said there are no reflection notes stored from the previous year. So the first function I defined was an action function. No real data structures here. It's just what are you here for? Are you here to plan or reflect? And then a little bit of data validation to make sure you put in a valid response. Hardiness zone, again, not a huge. So this one does use a data structure. It looks at the data frame that I imported over here, and it returns one row of that data as the function when it's called. Next, we have budget. This is just asking the user for their budget, no data frame, or we're just a simple returning an integer. This one does manipulate and use the data frame quite a bit. So this is select veggies. So what we want to do is provide the user with all the veggies that they can choose from. So we output, basically we do include an index column. I created one here, and then we attach the vegetable name to each index so that they can input a series of numbers separated by spaces so that they can indicate which vegetables they want to plant. And then we just make sure that it's a valid response over here. We spit out what they've chosen, and then we return a list actually of all the selected veggies so that we'll use that list in a lot of the other functions. So the next one is a veggie check. Basically, for our hardiness zones, let me show you. As you go down in zone, starting in 1, these are really like Alaska, really zones where you have a very, very short season to garden. There are some crops that exceed the season length. So an example, which I'll show you when I do the demo, is thyme. Thyme is a very, very slow grower. So the average days till harvest is 180. So if you're trying to plant in pretty much zones 1, 2, 3, or 4, you can't successfully plant thyme unless you buy it from a nursery, or if you start the seed indoors, which we don't account for in this project. So that's what the veggie check function does. It basically just wants to make sure that all of your vegetables can be planted in your zone, and if they can't, it basically returns a list with all of the unplantable plants. And then in the main function down here, we go through the list and we just say, hey, this won't work, we need to remove it, and then your remaining selection, we just drop it from the selection. So after the veggie check, over here, a little bit out of order, we have a reflection. If you come and use the function just to update your notes, it simply updates the text string, and you can either replace or append to that text string. Over here for square foot veggies, this is basically looking at the total gardening space you have available. I kept it constant for now. A future improvement would be, of course, to make it dynamic for other people to use. I just based it on my garden beds. And as you ask the user, hey, how many square feet do you want in each one for each one of your vegetables, it just makes sure that they're not over planning and trying to add too many square feet and going over the amount of or the size that you have. And then this is where we use our dictionary. And so again, we're asking the user, we're using the user input, and we're using our vegetable as our key. and the amount of square feet that we want for that vegetable as the value for that key. And it returns a dictionary with that information. Second to last function, budgeting. So this takes the budget from before that the user put in, and after they selected their vegetable, it goes back to our main data frame, which is the veggie traits import, and it looks at all of the startup costs. It actually only takes one. It doesn't take into account how many square feet you plant of each, because normally when you buy a seed packet, there's plenty of seeds. So especially for the size of my garden, I don't have to worry about buying multiple seed packets. And basically it just compares the startup cost, and it'll either tell you that you're over budget or that you're in budget, and then it'll, I use a filtering function to basically do to spit out two columns instead of spitting out the whole data frame, so that they can look at the breakdown on how much everything costs and how we got to the planned cost. Last one, dates. So based on your hardiness zone, we basically want them to have a plan of when they should start planting things or sowing seeds in their garden. So this is not a very sophisticated, in the future you can take into account, for example, eggplant, you don't necessarily want to start day one. You want to start it when the temperatures reach up to, 50 degrees as a low. But in this case, base example, we're going to start all of our vegetables day one so we can get as many vegetables in as we can during the harvest season. And it'll basically give you your harvest window. So I was able to add two columns based on other columns. So one of them is just using the start date, and then the other one is adding the days until harvest to the start date, converting that using time delta to days, and then adding it to the start date, and then dropping again using that filtering feature to drop irrelevant information, so that when we print this data frame, our users just have the relevant information. So this is my main function down here. And so I'm going to run it and do a little bit of a demo. So you come in and it asks you, are you P for planning or R for reflecting? If I put in, not P or R, it says your input was invalid. So type P for planning or R for reflecting. I'll start off with P for planning. And so what is your hardiness zone? I'm going to put in 1, even though technically in Colorado our hardiness zone over here is 5. And so it says you have the following vegetables to choose from. And so here's our index, here's our vegetable name, and it says please use numbers 1 through 36 separated by spaces to indicate what vegetables you would like to grow. So let's say I want to grow basil, some beets, broccoli, skip down a little bit, let's grow some dill, onions are great, love okra. Doesn't have to be in order. I can go out of order and go back up to, cauliflower. And then I do want to put time in here so you can see what happens when I try to plant something that isn't appropriate for my hardiness zone. So after I submitted my input over here, you can see you have chosen index, vegetable name, so I'm able to see which vegetables I chose. Due to hardiness zone restrictions, we need to remove time from our veggie selection. Your remaining selection is, and then it gives us that list of what we still have. Now we will go through each veggie you've chosen to determine how many square feet you want of each. So we'll just start at the top, basil, enter a whole number. If I try to enter an alpha numeric, I do get oops. I thought I had a validation for that, so that was a bad example. I'm just going to run this again really quick and enter a lot of the same stuff. And okay, how many square feet would you like for basil? Let's just say 1 for now. Square feet for beets, let's say 2, broccoli 3, and Brussels sprouts 4. Now I have to type in my budget. So let's say I'm really struggling. I only have $20. That's all I have. So my garden plan will cost you $19.80. So we are in budget, and here's our breakdown. So you can see the 4 vegetables I chose. Again, time was removed and how much each thing costs. And then it says, based on your hardiness zones, you can plant at the following dates and harvest at the following dates. So again, you have the vegetable name, your plant date, and your harvest date. So you can take that and, go garden. Starting on, based on our hardiness zone, we can start gardening in May. And most of our crops will be out by July and August. Really quick to talk about some future improvements that I would have definitely loved to incorporate if we had a little bit more time. A zip code to a hardiness zone. So instead of people knowing their hardiness zone, it would be helpful if, everyone knows their zip code, you could put that in. And I would have to get a data frame with pretty much all the zip codes in the US and then map it to the corresponding hardiness zone. And that data is out there. Dynamic bed mapping, we talked about being able to increase the size based on your garden at home. Harvest amount backwards planning, so that would be like, okay, I want 20 pounds of potatoes, so how many do I have to plant? That would be really helpful for people too if you're, planning to make a lot of tomato sauce. Planting 2 crops, so that's if you want to have a spring and a fall harvest. So that again would just need a few more variables. It also is based on your hardiness zone and whether you start seeds indoors, if you have that set up to be able to do that or not. So that would be another parameter or variable we could get from the user. Have a main menu, so just due to lack of timing, as you can see, it's 3 minutes till submission. I couldn't create a main menu, but I hope that I can make an improvement. Companion planting, that would be, I showed you the FOs and mapping crop rotation, and I showed you that data frame too. So that's it.